What the Earth looked like before you, before humanity, before trees, before even the first single cell. What if you could travel back in time, not hundreds of years, not thousands, but billions, and watch our planet being born? Today, on Path of Knowledge, we take that journey. A journey into the deep past, where the Earth was not the peaceful blue world we know, but a place of fire, chaos, transformation, and unimaginable beauty. What you are about to hear is the story of Earth itself. In the beginning, there was no Earth, only a swirling cloud of dust and gas orbiting a newly formed star, the Sun. Around 4.6 billion years ago, gravity began pulling this cosmic dust together. Piece by piece, rock by rock, microscopic particles collided at incredible speed, fusing into bigger and bigger bodies. Scientists call this violent process accretion. Over millions of years, these tiny fragments grew into a molten protoplanet. This was the earliest Earth, not a solid world, but a glowing sphere of magma constantly bombarded by giant space rocks. One impact was so huge that it changed everything. According to the giant impact hypothesis, a Mars-sized body, named Theia, collided with young Earth, blasting molten debris into space. That debris eventually gathered into a new companion we know today as the Moon. The collision also remelted Earth completely, resetting the clock of our planet's early history. As the Earth cooled from its global ocean of fire, something extraordinary happened. Heavy metals like iron sank downward, forming the core, while lighter rocks floated upward to create the mantle and crust. This separation created Earth's magnetic field, an invisible shield that protects life today from deadly solar radiation. Without this magnetic protection, life could never have emerged. This stage in Earth's development, though violent, was essential for everything that would come later. But this new world was nothing like ours. For hundreds of millions of years, the young Earth was covered by volcanic eruptions, toxic gases, and meteor storms. The sky glowed red, the air was unbreathable, and lightning cracked across a hostile landscape. Scientists call this era the Hadean Eon, named after Hades, the realm of fire. Yet even in this chaos, the building blocks of life were already forming. Water vapor from volcanic eruptions condensed as Earth cooled. Torrential rains lasted thousands of years, filling the basins of the planet and creating the first oceans. Some water also came from icy comets and asteroids that collided with Earth. By 4.3 billion years ago, the first global oceans shimmered under a still glowing sky. Deep within these oceans, chemistry began to work its magic. Scientists today suggest that life may have begun around hydrothermal vents, cracks in the seafloor where superheated water rich in minerals gushes out. These vents create extraordinary chemical gradients, providing energy that early molecules needed to combine, replicate, and evolve. Studies of ancient rocks from Greenland and Australia show chemical signatures of life dating back 3.8 billion years, and certain microfossils suggest that simple microbes may have existed even earlier. Life began quietly, not with plants or animals or anything visible to the eye, but with tiny single-cell organisms that slowly transformed Earth forever. As these primitive microbes multiplied, they performed chemical reactions that changed the composition of the oceans and atmosphere. Some of them, like cyanobacteria, developed an ability that changed the planet permanently: photosynthesis. For the first time, sunlight became a source of fuel, and with photosynthesis came a byproduct that would reshape Earth's destiny: oxygen. At first, this oxygen reacted with iron in the oceans, forming rust that settled as banded iron formations we still find today. But after hundreds of millions of years, oxygen began to accumulate in the atmosphere. This event, known as the Great Oxygenation Event, occurred about 2.4 billion years ago. To early life, oxygen was toxic, causing mass extinctions. But for the future of complex life, it was a blessing. Without oxygen, breathing creatures like humans could never exist. Oxygen also formed the ozone layer, which shielded the surface from harmful ultraviolet radiation. For the first time, life could explore environments outside deep water. But before that could happen, Earth needed to undergo another transformation, one driven by geology. The planet's crust was not a single solid shell. Huge slabs of rock floated on the semi-molten mantle beneath, moving slowly over millions of years. This process, plate tectonics, created mountains, oceans, volcanoes, and continents. Early Earth's continents were small and scattered, but through collisions and separations they grew and reorganized into new supercontinents multiple times. Around 1.3 billion years ago, a supercontinent called Rodinia formed. It eventually broke apart, reshaping the oceans and climate. During one of these breakups, Earth may have plunged into a catastrophic freeze. Geological evidence suggests that around 700 million years ago, the entire planet froze from pole to equator, a period scientists call Snowball Earth. Glaciers thousands of meters thick covered everything, but volcanic activity beneath the ice continued, releasing carbon dioxide. Over millions of years, CO2 built up in the atmosphere, trapping heat and melting the ice in a rapid global thaw. This climate shock may have triggered an explosion of life. Around 540 million years ago came the Cambrian Explosion, a moment in Earth's history when complex organisms suddenly appeared in extraordinary variety. Creatures with eyes, shells, legs, and brains emerged in the oceans. Ancient relatives of insects, fish, and even ourselves made their first appearance. The Burgess Shale fossils from Canada show a snapshot of this diversity in incredible detail. With oxygen levels rising and ecosystems expanding, Earth was primed for life to conquer new territories. Plants were the first to make the leap onto land, around 470 million years ago. With sunlight abundant and no predators, they spread rapidly, turning barren rock into green landscapes. Their roots broke down stone, creating soil. Their leaves released oxygen, enriching the atmosphere. Soon after, animals followed. Insects crawled across the ground. Amphibians emerged from rivers and lakes. Forests grew so dense that oxygen levels soared higher than today. Giant dragonflies with wingspans over 2 feet flew through prehistoric swamps. But Earth's story is not only about creation, it is also about destruction. 5 major mass extinctions have reshaped life. The Permian extinction, 252 million years ago, was the worst, wiping out more than 90% of species. Scientists believe massive volcanic eruptions in Siberia released toxic gases, heating the climate and acidifying the oceans. Yet after this apocalypse, new life forms evolved. Among them were the dinosaurs, who would dominate Earth for more than 160 million years. Dinosaurs lived through changing climates, rising and falling sea levels and shifting continents. But their reign ended dramatically 66 million years ago when a 10-kilometer-wide asteroid struck near present-day Mexico. The impact released more energy than 1 billion nuclear bombs, creating fires, tsunamis, and darkness that lasted months. When the skies cleared, the dinosaurs were gone. But in the shadows, small mammals survived. Over millions of years, they evolved into diverse forms, some returning to the sea as whales, others adapting to forests, grasslands, mountains, and finally, some giving rise to early humans. Around 300,000 years ago, the first Homo sapiens appeared in Africa. We spread across the globe, shaped by Earth's landscapes, climates, and resources. The planet that formed from fire and chaos now became home to beings capable of understanding its history. Today, when we look at the Earth from space, a quiet blue marble, it's hard to imagine the storms of creation it survived. But every mountain, every ocean, every breath of air carries a trace of those ancient transformations. The iron in your blood was forged in stars that died billions of years ago. The oxygen you breathe was made by microbes long before humans existed. Even the continents beneath your feet are fragments of world-sized collisions. Earth's story is not finished. It continues every day, through shifting tectonic plates, evolving climates, and the actions of life, including us. Understanding this story reminds us that the planet is not a static object. It is alive, dynamic, fragile, and precious, and we are part of its latest chapter. So the next time you see the sky glowing at sunset, the waves crashing on a beach, or the mountains rising on the horizon, remember, these are not ordinary sights. They are echoes of a 4.5 billion year journey. A journey of fire, ice, oceans, continents, extinctions, rebirths, and evolution. A journey that made life possible, and a journey that continues, shaping the world we will pass on to future generations. This is Path of Knowledge, and this was the story of our Earth.